This is an exercise on exponential equations, part 1. We'll be actually covering two types. And the first one today is where the unknown is in the base. And I call these type 1, although that's just my definition, my term for it. And rather than get into a detailed explanation of what you're working with, I'll just launch into some equations of this type. So it's where we have the unknown in the base. So that is, the variable x is in the base, and we will have an exponent, a numeric one. So 3/4 is equal to 27. So some number raised to the exponent 3/4 will be equal to 27. And the method for solving these, rather than trying to fumble your way through, we do the same thing every time for this type of problem. To get rid of that unwanted exponent, we just use sort of regular algebra. We get rid of it and we raise both sides to the reciprocal. So the reciprocal of 3/4 is 4/3. So that eliminates it and leaves us with just x to the 1. Thing of it is, you do that to the one side, you must do it to the other side. So that's the algebra part. So I raised that like this. And the next step would be just to illustrate this as x by itself is equal to 27 to the 4/3. And although you can just push it through your calculator the way it is, and many of you will do that, I'm going to continue to use the traditional breakdown method for a lot of these. That's equal to the cubed root of 27 to the exponent of 4. And that means that x is equal to 3, which is the cubed root of 27, to the 4, taking us to x equal 81. So we use this method for every question we see of this sort. So I'm going to go through like another 5 or so, 6 maybe, examples and showing variations of it. So x to the negative 4/5 is equal to 81. Now I'm going to work this one out by hand. Thing is, when you get something like this, do not be thrown off by the negative exponent. Now some of you might be tempted to write this as 1 over x to the positive 4/5. And actually that's not wrong. It'll still take you to the answer. But it's not necessary. If you keep in mind that you're just trying to get x by itself, why not raise both sides to the negative 5/4? And that way you get rid of it, and then the negative is really just taken to the other side. Now 81 to the negative 5/4, again you could just push it through. But I will write this as 1 over 81 to the 5/4. And then x is equal to 1 over the 4th root of 81 raised to the exponent of 5. The 4th root of 81 is 3, and then 3 to the 5 is 243. So that's our answer. Let's try another one. This one's a little more complicated because we have two x terms. So x is equal to 64 divided by x to the 1/2. And once again we do fairly routine algebra on it. I like to think of this as just a regular proportion, so I would cross multiply. The other thing is just multiply both sides by x to the 1/2. But this is what we get. We get x times x to the 1/2 is equal to 64. Now that may not look much better, but in fact it is, because if you consider that this x is really just x to the 1, to simplify the left side of the expression, we add exponents. 1 plus 1/2 equal to 64. Get a common denominator between the two, so that would be 2. So 2 over 2 plus 1 over 2 is equal to 64. You could just use your calculator as well, and I think many people at this stage are. But this becomes x to the 3 over 2 is equal to 64. To get rid of that exponent, we can at last raise it to the 2/3. And this will give us x is equal to the cube root of 64 raised to the exponent of 2. Now the cube root of 64 is equal to 4, and then 4 squared will bring us to 16. So even though the equations look a little harder, stick with the method and you'll be okay. Let's take a look at another one. 2 times x to the 5 halves is equal to 64. Now don't pull the trigger too quickly by getting rid of that exponent. The problem is we have this factor of 2. So just use regular algebra again, divide everything by 2. So we get x to the 5 over 2 is equal to 32. And then to get rid of that exponent 5 over 2, we raise it to the 2 over 5. And that becomes the 5th root of 32 raised to the 2. And you could do the same thing that we always do, or you could do it quicker. 5th root of 32 is 2, and then 2 to the 2 gives us x is equal to 4. I'll bring up a new screen. This one is very similar to the previous one, except that the 3 is, or the number, the coefficient, is in brackets. So before you can do anything with this problem, you have to either take that 3/5 into both of the terms, which I don't recommend, or better still, just get rid of the 3/5. So raise both sides to the 5 over 3, and that becomes 27 to the 5 over 3. And then we get 3x is equal to the cube root of 27, all raised to the exponent of 5. I'm going to do this one in one step. The cube root of 27 is 3. 3 to the 5 is 243. And now we can divide by that 3, giving us x is equal to 81. So you start to see the same numbers repeating over and over again. Most, but not all of these questions are cooked up to give you like 2s and 3s. Do another one, kind of the same thing, except here we have a binomial in brackets, and it's not really a big stretch from the previous one. We just have to remember that this 1/3 we get rid of by raising to the 3, or the 3 over 1. So 2x minus 1 is equal to 3 cubed, which is 27. Add on 1 to both sides, so regular algebra now. So 2x is equal to 28. And then divide by 2. X is therefore equal to 14. So the same method exactly. Just be careful. Don't try to do anything weird with that 1/3. By, you cannot distribute it into that bracket or however you want to think of it, because you are subtracting those two terms. Your only hope is to get rid of that outer exponent. The last one, x to the 2.7 is equal to 58. And this one is not difficult, but it'll throw people because of the decimal and the exponent. But don't do anything different. If you want to get rid of that 2.7, you just raise it to 1 over 2.7. And then do the same thing. You go 58 raised to the 1 over 2.7. Now, I know you're probably thinking, why don't I take that 2.7 and write it as 2 and 7 over 10, and then 27 over 10, and do that? And yes, the answer is you could do that. But your calculator handles decimals very well, so there's no real advantage in doing it. Be careful, because when you use your calculator with this, you will have to open and close a bracket, unless you want to use the reciprocal key. But most people prefer this. And we're taking this one to the nearest tenth as per the instructions. So you get something like 4.499, as I recall. And then to the nearest tenth, careful with the round, you'll get x is equal to 4.5. And there we go. So that's the type of question that you're dealing with, always with the unknown in the base. So the trick is getting rid of that unwanted exponent. So thank you for your time.